folks, Mr. G here with another educational video. Today we're going to be talking about word problems, and in particular what sort of word problems we can solve using our equation solving that we've been going over the last few days. Before we jump into that though, a lot of times these word problems are going to involve taking these sorts of word sentences that we talked about way back at the start of the week and making those into algebraic expressions. So taking something like a number plus 2 and turning that into x plus 2, or the quotient of 4 in a number, turning that into 4 over some variable like z. Being able to go from words to algebraic expressions is the really sort of core skill when it comes to solving word problems that involve equation solving. Now there's 4 types of word problems that we're going to be going over. Obviously, there are other types of word problems, and this is going to cover all of them, but these 4 different sort of main types cover a lot of the key skills, as well as highlight some of the differences between the types of word problems and give you a few techniques for tackling them. Our first type of problem are the types of problems where they just give you some information about some mystery number. In this case, we're told a number, the quotient of that number and 5 reduced by 4 is 8, and we're asked, what is that number? Anytime you're doing this word problem here and you're turning words into variables, the first thing you want to do is a let statement. And let just means that we're going to call a variable like x this number here. This tells us what our variable represents. In this case, it's whatever this mystery number is. Once we have this, now we can turn this sentence into an algebraic expression or an algebraic equation. So we're told the quotient of a number and 5. This section right here, we know this is x over 5. Reduced by 4, reduced, that's like subtraction, by 4, this is like our equals sign, and then 8 was just the number 8. So now we can take this sentence and turn it into an algebraic equation. And once we're here, now we're just solving an equation. We've done these a bunch of times. We spent the last 2 classes going over this. So now, variables on one side, numbers on the other. So we'll add 4 to both sides of this equation. We got to get rid of this denominator, so we'll multiply both sides by 5. And we'll get our answer, our mystery number. That number is 60. But wait, we almost forgot something. We still need to check this. And like with any question that involves an algebraic equation, we can take our answer, plug it back into the equation that we got, and see if it's right. So here it would be 60 over 5 minus 4. 60 over 5 minus 4, is that the same as 8? 60 over 5 is 12 minus 4. 12 minus 4 is 8. Get 8 on both sides, so we know we got the question correct. All right, the second type of problem is what are often called coin problems. So in this case, we've got a jar of 44 coins with pennies, nickels, and dimes. If you've forgotten, pennies, that's like 1 cent. Nickels, 5 cents. Dimes is 10 cents. Though as it turns out in this question, the fact that they're pennies, nickels, and dimes isn't super important. Sometimes it is, but in this one it isn't. Because all we're told is that there are 2 more pennies than dimes and 3 fewer nickels than dimes. How many of each coin are there in the jar? So we don't actually care about what the values are, we just care about how many there are in the jar. First key piece of information here is 44 coins. So that tells us our total. And then we're told some information about the number of pennies compared to the number of dimes, compared to the number of nickels. So here, I'm going to start off with my let statement. And in this case, I'm actually going to define a couple of different variables. So I'm going to say P is the number of pennies, D is our number of dimes, and N is our number of nickels. And we know that our total, so we have 44 coins in total, should be equal to the number of pennies plus the number of dimes plus the number of nickels. But we don't know how to solve equations like this where we've got a bunch of different types of variables. So what we're going to need to do is use these other pieces of information, the fact that there are 2 more pennies than dimes and 3 fewer nickels than dimes, to help us answer the question. So let's highlight this one, 2 more pennies than dimes. So that tells us the number of pennies should be equal to the number of dimes plus 2. The number of pennies is 2 more than the number of dimes. So the number of pennies is the number of dimes plus 2. 3 fewer nickels than dimes. Well, that tells us that the number of nickels is equal to the number of dimes, but minus 3. There are 3 fewer nickels than dimes, dimes minus 3. So what that tells us is now that our equation, we've got dimes minus 3 for our nickels and dimes minus 2 for our pennies, is we could actually use these here. So the number of pennies is the same as the number of dimes plus 2. And the number of nickels is equal to the number of dimes minus 3. And now we have an equation that we can actually solve. First thing, let's group all of our like terms on this side. Let's clean this up. We've got 3 copies of our variable d, so that tells us we have 3d. Positive 2, negative 3. Those are like terms. That would give us negative 1. Variables on one side, numbers on the other. We're going to add 1 to both sides of this equation. We'll get 45 is equal to 3d. And then we can divide both sides by 3 to get rid of the number in front of our variable. And we'll get the number of dimes is equal to 15. But wait, we haven't answered the question. We want to know how many of each coin there are. But fortunately, we already know how to get from our number of dimes to the number of each other type. We know that the number of nickels is equal to the number of dimes minus 3. So 15 minus 3, that tells us that the number of nickels is 12. And same thing for our pennies. The number of pennies is equal to the number of dimes plus 2, so the number of pennies is equal to 15 plus 2, which is equal to 17. And before we move on with our question, we got to check it. We should end up with 44 coins when we add up our pennies, our dimes, and our nickels. So 15 plus 17, so that's our dimes plus our pennies plus our nickels. Does that all add up to 44? 15 plus 17, that's 32. 32 plus 12, that's equal to 44. And there we go. We got the same number on both sides. So we know we got this question right. The third type of common word problem are age problems. So something like Bob is 6 years older than his sister Lisa, and the sum of their ages is 32. We want to know how old Bob and Lisa are. In this one, we've got 2 different numbers we're trying to solve for. The ages for Bob and Lisa. So let's let B be Bob's age and L be Lisa's age. If Bob is 6 years older than Lisa, that would tell us that Bob's age is got to be Lisa's age plus 6. And we're also told the sum of their ages is 32. So Bob's age plus Lisa's age is equal to 32. But now we can use this piece of information that Bob is 6 plus Lisa's age. We can substitute that in. So Bob's age is Lisa's age plus Lisa's age should give us 32. Let's gather up our like terms here. So we have 2 times Lisa's age plus 6 is 32. We can subtract 6 from both sides of our equation here. And then finally we can divide both sides of our equation by 2, and we'll get that Lisa's age is 13. And just like with our coin problem, now we can figure out Bob's age, which is Lisa's age plus 6. So that's like 13 plus 6, which tells us Bob is got to be 19. And as always, we want to check our answer. This is a pretty easy check. The sum of their ages is 32. So is 19 plus 13 equal to 32? Without too much trouble, we can see 19 plus 13 is equal to 32. Same on both sides, so we know we got the right answer. The last common type of problem that we see for these word problems are geometry. So usually talking about the perimeter or the area of a shape, for instance, a rectangle. So here we're told that the length of a rectangle is 10 centimeters more than its width, and our perimeter is 48. And we want to know what the dimensions are. Now, if you don't know, when it's talking about dimensions, that just means the length and the width. So we're going to be solving for 2 things, the length and the width, which tells us that we should probably start with a let statement where L is going to be our length and W is going to be our width. Now we're told that the length is 10 centimeters more than the width, so that means our length is equal to the width plus 10 centimeters. If we were to draw this as a picture, this would be our width, and then our length would be our width plus 10. Now we know that the perimeter is 48, and we could calculate that perimeter based on our shape here. Remember, perimeter's all the way around. This would be equal to W plus 10 plus W plus W plus 10. So all of our sides added together. And once we're here, now we can solve this equation. Let's gather up our like terms. We've got 4 copies of W and 2 copies of 10, which gives us 20. Let's subtract 20 from both sides of this equation. Now we can divide both sides of our equation by 4, and we've just solved for the width. But remember, we got to solve for the length as well. We're asked for the dimensions, which is length and width. But fortunately, we already have an equation for it. Length is width plus 10. So our length is equal to our width plus 10, which is, in this case, 7 plus 10. So our length is going to be 17. Let's finish off by checking this. Our perimeter should be 48. So our perimeter should be equal to our length plus our width plus our length plus our width. 7 plus 17, that's 24, plus another 17, plus another 7, gives us our answer, 48 on both sides. So we know we got this right. Alrighty folks, let's check your understanding. 4 questions on the screen here. Grab a piece of paper, pause the video, and try them out for yourself. Then, when you're done, you can unpause the video and we'll go over the answers together. All done? All right, let's go over the answers. The first one here, this is like our type 1 question where we have some information about a number. We're told the product of a number and 4, that's like 4 times our number. Let's let x be the number. So 4 times our number increased by 6, that's like plus 6, is equal to, there's our equal sign, is equal to x again. Once we have this, now we can assemble our equation. We'll have that 4x plus 6 is equal to x itself. Now for this question, we want to make sure that our numbers are on one side, variables on the other side. In this case, our number's already over here, but I'm going to move my variable over to the other side. So I'm going to have to subtract 4x from both sides. Once I'm here, I can divide both sides by -3, and we'll get the answer that x is equal to -2. As always, it's a good idea to check. So is 4 times -2 plus 6 equal to -2 when we substitute in x into this equation right here? 4 times -2, that's -8 plus 6. -8 plus 6 is -2, which matches our other side, so we know we got the question right. For this one here, we're talking about the perimeter of a triangle. Triangle has 3 sides, so let's name those sides. Let's let the first side be equal to A, our second side will be B, and our third side, let's call that C. So now we can use this information here. First off, the perimeter of our triangle is 40 millimeters, and that would be equal to A plus B plus C. Just realized that I put in centimeters for these units here. They should have been all millimeters. So if that messed you up, my bad on that one. That should have been millimeters. So for this one here, our first side is 6 millimeters shorter than the second. So that tells us our first side, A, is equal to our second side minus 6 centimeters shorter than the second side. And our third side is 7 centimeters longer than the second, so our third side is equal to the second side plus 7 more centimeters, or millimeters, sorry. Now we can use these and write this whole equation just in terms of our second side, B. A is B minus 6 plus B plus 7. Now we can group together our like terms. We've got 3 copies of B here. -7 plus 6 is like plus 1. We can move the 1 over to the other side by subtracting 1 on both sides. And then we can divide both sides by 3. And we'll get that our second side is equal to 13. But now we got to figure out our other 2 sides. We know our first side, A, is equal to B minus 6. So that would be 13 minus 6. So our first side would be equal to 7 millimeters. And our third side, C, is equal to B plus 7. So 13 plus 7, which is equal to 20 millimeters. And to check our question, all we would have to do is make sure that all of these added together, 7 plus 13 plus 20, gives us our perimeter of 40. 7 plus 13 is 20, plus another 20 would give us 40, so we know we got the right answer. Our next one, we've got a jar of coins, and we're told some information about them, and we want to know how many of each coin. We've got quarters, dimes, and loonies. So let's let Q be the number of quarters, D be the number of dimes, and L be the number of loonies. So we've got 52 in total. That tells us that quarters plus dimes plus loonies is equal to 52. So I just made another typo here. My apologies. 2 more dimes than loonies. So again, if this said nickels beforehand and nickels here as well, that should have said loonies. My apologies. So the number of quarters, dimes, and loonies should be equal to 52. We can use this first piece of information, 2 more dimes than loonies. So that tells us the number of loonies is equal to the number of dimes. That tells us the number of dimes is equal to the number of loonies plus 2. There's 2 more dimes than there are loonies. 3 times as many quarters as loonies. So that tells us the number of quarters is equal to 3 times the number of loonies. 3 times as many quarters compared to the number of loonies. So we'd have to take the number of loonies multiplied by 3 to get us the number of quarters. Now we can use those 2 in our equation here. So we get the number of quarters is equal to 3 times the number of loonies, plus the dimes is loonies plus 2, plus the loonies equals 52. We've got 3, 4, 5 copies of the number of loonies. Now we can subtract 2 from both sides, divide both sides by 5, and we'll get the number of loonies is equal to 10. Now we can figure out the number of quarters, which is 3 times 10. So the number of quarters would be equal to 30. And the number of dimes is equal to 10 plus 2, which is equal to 12. And also we can check this one. We should be able to add all these together to get 52. So 30 plus 10 plus 12 should be equal to 52. That's 40 plus 12 is 52. So as we can see, all our coins add up and we can get our right answer. Last one's pretty tricky here. Samantha's father is 6 more than 3 times her age. The difference between their ages is 30. How old are each of them? There's 2 ages here. So for our variables, let's let S be Samantha's age. And we don't know the name of her father, but we'll use F for the father's age. We're told that Samantha's father is 6 more than 3 times her age. So 3 times her age would be 3 times S, but 6 more than that is plus 6, so that would give us the father's age, 3S plus 6. The difference between their ages is 30. So we know the father's going to be older, so that tells us that the father's age minus Samantha's age should be equal to 30. So if we use this equation that we have up here, we have that the father's age is 3S plus 6 minus Samantha's age should be equal to 30. 3S minus S would give us 2S. Now we can subtract 6 from both sides, divide both sides by 2, and we get that Samantha's age is 12. And now we just have to figure out her father's age. 3 times 12 plus 6. So 3 times 12, that's 36. So that tells us that her father's age is 42. Now we want to check this. So we know that the difference between their ages should be 30. So 42 minus 12, is that the same as 30? 42 minus 12 is 30. So we know we got the right answer. That's the end of the video here. Apologies again for all of the typos and mistakes here, but thanks for tuning in. Please make sure you check Teams for all of our daily homework, assignments, as well as any other announcements, and I will see you all in the next video.